Gay-Lussac's law of gaseous oleum. Okay, let's discuss what is Gay-Lussac's law of gaseous oleum. Before that, check the statement of the law. When gases combine or produced in a chemical reaction, they do so in a simple ratio by oleum provided all gases at same temperature and pressure. Okay, that's the law. Once more, in the case of gaseous oleum, the product formed in such a way that they combine by the simplest ratio of their oleum. Let's check an example. For example, hydrogen combines with oxygen, we get H2O, water. And by balancing the equation, we put half here. So, H2 plus half O2 gives H2O. That's the reaction. Suppose we take 100 liter of hydrogen gas and half of oxygen, 50 liter of oxygen gas, and we get 100 liter water. Okay, so we can say the hydrogen and oxygen, these two are the reactants, they combine in the simplest ratio. We can say it is what? 2:1, simplest ratio by oleum. That's the law, Gay-Lussac's law of gaseous oleum, and this law obeys only for gaseous reactants and the product. Also, one more thing, what's the important thing that we want? Yes, they are all gases are at same temperature and pressure. If all gases are at same temperature and pressure, they combine in simple ratio by the oleum in order to get the product. Is it clear? For example, hydrogen combines with oxygen, we get water, and if we take 100 liter of hydrogen and we take half of oxygen, 50 liter of oxygen. So by simple ratio, it's in the ratio 2:1. This is the what? Yes, Gay-Lussac's law of gaseous oleum. Once more, when gases combine or produce in a chemical reaction, they do so in a simple ratio by oleum provided all gases are at same temperature and pressure. At the condition of same temperature and pressure, all the gases combine in simple ratio by their oleum. That's all. That is Gay-Lussac's law of gaseous oleum. And we discussed what? Law of conservation of mass, then definite proportion, multiple proportion, and another one is what? Gay-Lussac's law of gaseous oleum. And the last law in this chemical combination is Avogadro's law. Let's check what is Avogadro's law. And the last law in law of chemical combination is Avogadro's law. And we already discussed, yes, law of conservation of mass, law of multiple proportion, law of definite proportion, then Gay-Lussac's law of gaseous oleum. And the fifth law in that category is the Avogadro's law. And let's check the statement. What is Avogadro's law? Equal volume of gases at the same temperature and pressure should contain equal number of molecules. That's the law. That means if two gases present the same volume at the same condition of temperature and pressure should contain equal number of molecules. That's Avogadro's law. For example, at STP means standard temperature and pressure. That's a condition. And standard temperature and pressure means 273.15 Kelvin temperature and 1 bar atmospheric pressure. 1 bar atmospheric pressure. At that condition, all gas occupies an volume of 22.4 liter. Okay, that's the STP volume. STP volume means the gas at STP condition exists in this particular volume. STP condition means standard temperature and pressure. And standard temperature means 273.15 Kelvin temperature and standard pressure means 1 bar atmospheric pressure. At that condition, all the gas contain same number of molecules. If we consider as n number of molecule, Then all the gas, for example, carbon dioxide. Carbon dioxide at STP, the volume is taken as 22.4 liter. It contains Avogadro number of molecule. We can say like this, Avogadro number. And the number, Avogadro number is 6.022 into 10 raised to 23. That we consider as 1 mole. Or the particles present in 1 mole, that's Avogadro number. Clear? We can say at STP condition all gas. Another one, ammonia, NH3 gas. At STP, the volume is 22.4 liter. It contains the same number of molecules. Avogadro number of molecules. Whatever the gas at STP or at a condition of the constant temperature and pressure, it contains same number of molecules. That is Avogadro's law. Listen, equal volume of gases at same temperature and pressure should contain equal number of molecules. Once more, equal volume of gases at same condition of temperature and pressure should contain equal number of molecules. Is it clear? Yes. And with this, the laws of chemical combinations completed. Once more, which are the laws of chemical combinations or which are the laws present in chemical combination? Yes, law of conservation of mass, law of multiple proportion, law of definite proportion, Gay-Lussac's law of gaseous volume, and last one, the fifth law in that category is Avogadro's law. It states that equal volume of gases at the same temperature and pressure should contain equal number of molecules. And we consider STP volume. At STP, standard temperature and pressure, we calculated the volume of any gas at 22.4 liter that contain Avogadro number of molecules. Avogadro number means this is the Avogadro number 6.022 into 10 raised to 23, and that means the amount of substance present in 1 mole. Next one is a theory. You already studied that theory in the lower class. I just say the theory. Dalton's atomic theory. Okay, and we know atom. Atom means the smallest indivisible particle, that is atom. Come from the Greek word atomos. We know. And in 1808, Dalton put forward a theory and it is known as Dalton's atomic theory. And let's see the postulates of this theory. The first postulate, matter consists of indivisible atom. We know what is matter. Yes, anything that has mass and occupies space is called a matter. And these atoms are made up of small particles and we call these small particles as atoms. And these atoms are in continuous motion, or the atoms attract each other. These are the properties of matter. The first point, what's the first postulates of Dalton's theory? Yes, matter consists of indivisible atom. Matter means anything that has mass and occupies space. Any matter consists of lots of atoms. They are indivisible. That's the first postulate. And next postulate, all the atoms of given element have identical property. Atoms of different element differ in mass. For example, if we take the element carbon, all the atoms present in the carbon show same property. Another example, nitrogen. All the atoms present in nitrogen shows the same property. That's the point. All the atoms of given element have identical properties. Then atoms of different element or atoms of different element differ in mass. For example, carbon. The mass of carbon. What's the mass of carbon? Yes, 12. But the nitrogen, 14. They differ by mass. Okay. That's the point. All the atoms of given element have identical properties. Atoms of different element shows different mass. Then compounds formed when atoms of different elements combine in fixed ratio that we discussed in the law of definite proportion. For example, for the preparation of H2O, hydrogen and oxygen combine in the ratio 2:1. So different elements combine in fixed ratio to form what? Compounds. And next one, chemical reactions involve the reorganization of atom. That is, atoms can neither be created nor be destroyed. That's the law of conservation of mass. We know mass can neither be created nor be destroyed. Mass in the sense means atoms. Atoms also neither be created nor be destroyed. That's the last postulate. Once more, chemical reactions involve the reorganization of atom. There happen only a reorganization of the atoms already present in it. There is no creation, or atoms are not be created or be destroyed. That's the last postulate. Once more, the first postulate, matter consists of indivisible atom. At first we said matter consists of indivisible particles and we cannot name as atom. But Dalton said matter consists of indivisible atoms. All the atoms of given element have identical properties, but atoms of different element differ in mass. And compounds formed when atoms of different element combine in fixed ratio. And chemical reaction involved the reorganization of atoms already present in it. That is, there is no gaining or losing, or no destruction or creation of atoms takes place. Atomic mass. We know the atomic mass of different elements. For hydrogen, the atomic mass is 1. We know. Helium, it is 2. Then for carbon, it is 12. Oxygen, it is what? Yes, 16. Like that. What is atomic mass? And how the atomic mass is calculated? Yes. Atomic mass means the mass of that particular atom. And how we calculate the atomic mass? Yes, for that we consider a standard. The standard is carbon 12 isotope. What do you mean by isotope? Yes, compounds with the same atomic number but different mass number. There is isotope. We know the isotope of hydrogen, protium, deuterium, tritium. And here we consider carbon 12 isotope as the standard. Based on that, in that carbon 12 isotope, at the carbon 12 isotope we consider it contains 12 atomic mass unit or AMU. The carbon 12 is considered as what? It contains 12 atomic mass unit. Then what is atomic mass unit? Yes, we can define one atomic mass unit is the mass exactly equal to 1/12 of the mass of carbon 12 isotope. For example, suppose this one is the carbon 12 isotope. Now I divide this carbon 12 isotope into 12 equal parts. Okay, suppose I divide this carbon 12 into 12 equal parts. Okay, 12 equal parts. And in that, from that 12 equal part, I take this one part. Okay, I consider this part. And the mass of 1/12th of this carbon 12 isotope. Okay, and 1/12th of this mass, 1/12th of the mass of that particular portion is considered as what? Yes, one atomic mass unit. And we consider carbon 12 isotope as the standard for the calculation of mass. And the carbon 12, we consider carbon 12 contain how many atomic mass unit? Yes, 12 atomic mass unit. Then we want to know what is atomic mass unit. If we have a carbon 12 isotope and we divide it into 12 equal parts and we take any one of the parts and that part into 1/12 is equal to what? Yes, 1 atomic mass unit. Is it clear? Yes, 1 atomic mass unit is mass exactly equal to 1/12th of the mass of 1 carbon 12 isotope. Okay, equal to 1/12th of the mass of 1 carbon 12 isotope. Is it clear? That's about atomic mass unit, and numerically it is calculated as 1 atomic mass unit equal to 1.66056 into 10 raised to minus 24 gram. That is 1 atomic mass unit by considering carbon. And we take the hydrogen, atomic mass of hydrogen or the mass of one atom of hydrogen is calculated as 1.6736 into 10 raised to minus 24 gram. And in terms of AMU, first we divide what? The mass of this one by the 1 AMU. And we get 1.0080 AMU. By what? By calculating this, we consider hydrogen, the atomic mass is 1 AMU. It's actually 1.0080. But we consider as what? 1. Okay. And now the atomic mass unit is replaced by unified mass and is represented by the letter U. Is it clear? That's about atomic mass. For considering or for calculating atomic mass, we consider carbon 12 as the standard and the mass of 1 by 12th of a carbon 12 isotope. That's equal to what? 1 atomic mass unit. And we divide the carbon 12 into 12 equal parts. And what's the mass of one that part? And how much the mass of other atoms, comparing that 1 by 12th part of that carbon 12 isotope is considered as the atomic mass of that particular element. Is it clear? And 1 atomic mass unit, what is 1 atomic mass unit? 1.66056 into 10 raised to minus 24 gram. Next one is the molecular mass. We know what is atomic mass, and by considering the carbon 12 isotope, all the atoms have a particular mass. And we know how the molecules are formed. How molecules are formed? Yes, atoms combine together to form molecules. Atomic mass means the mass of that particular atom. For example, atomic mass of carbon 12, atomic mass of nitrogen 14, atomic mass of chlorine 35.5. That's atomic mass of that particular atom by comparing with the carbon 12 isotope. And some of these atomic masses are called what? Molecular masses. For example, H2O. What's the molecular mass of H2O? How we can find the molecular mass of H2O? Yes, 2 hydrogen atoms are present. So, 2 into atomic mass of hydrogen. What is atomic mass of hydrogen? 1. Then, plus oxygen. 1 oxygen atom is present. So, 1 into atomic mass of oxygen is 16. So, 16. What's the answer? Yes, 18. 18 is the molecular mass of, yes, water molecule. So, we can say molecular mass is the sum of atomic masses. The molecules are formed by combining different types of atoms, and the molecular formula or the molecular mass means what? It's a mass of all the atoms present in it. Another one example, H2O2. Hydrogen peroxide. There are 2 hydrogen atoms are there. So 2 plus oxygen, 2 oxygen atom. The mass of 1 oxygen atom is 16. Here 2 oxygen atoms are there. So what? 32. So 2 plus 32 is 34. Another one. C6H12O6. What is C6H12O6? Yes, glucose. And what's the molecular mass of this glucose? And carbon, atomic mass is 12. So 6 carbon atoms are there. So 6 into 12 plus 12 hydrogen atoms are there with atomic mass 1. So 12 into 1 plus oxygen. 6 oxygen atoms are there. Mass of 1 oxygen atom 16. So here 6 oxygen atoms are there. So 16 into 6. What's the answer? 180 is the answer. That's called what? Molecular mass. So clear? Atomic mass, molecular mass. Molecular mass is the sum of atomic masses, and atomic mass is calculated by considering carbon 12 isotope as the standard. Percentage composition. We know how to find the molecular mass of a particular molecule, and next task is to study percentage composition. The term itself says, what is percentage composition? Yes, percentage of particular element in a molecule. That's percentage composition. Normally we represent percentage in 100, so we multiplied with what? 100. That's all. Mass percentage of an element, otherwise called what? percentage composition is equal to mass of that element in that particular compound divided by total mass of compound multiplied with 100. Let's say example, mass percentage of all elements in water. We want to find mass percentage of all the elements present in water. Which are the elements present in water? Yes, hydrogen and oxygen, and 2 hydrogen, 1 oxygen in the ratio. So, H2O, water, we know the molecular mass of the water. H2O, 2 plus 16. So, 18 is the molecular mass of water. So, in order to find the mass percentage of hydrogen, first how many hydrogen atoms are there? 2 hydrogen atoms. The mass of 2 hydrogen atoms again equal to 2. So, 2 divided by molecular mass of the water 18 into 100 and we get 11.11 percentage. And next one, mass percentage of oxygen. How can we find? Yes, in water the mass of oxygen is what? 16. That 16 divided by total mass of what? That molecule H2O 18. So 16 divided by 18 into 100 equal to 88.89 percentage. Okay, this way we can find the mass of each element present in a particular molecule, and that's termed as percentage composition or mass percentage of that element. How we find the mass percentage? Yes, mass percentage of the element equal to mass of that element divided by total mass of a compound into 100. Next question is to find the mass percentage of all elements present in nitric acid. Nitric acid, the molecular formula HNO3. And here first of all we want to find what is the molecular mass of HNO3. And hydrogen, it's 1 plus nitrogen, 1 nitrogen, atomic mass 14 plus 3 oxygen atom, mass of 3 oxygen atom, 1 oxygen atom 16, so 3 oxygen atom 48. So 1 plus 14 plus 48 is equal to 63. Then hydrogen, only 1 hydrogen is present and mass of that hydrogen is 1. So 1 divided by total mass of nitric acid 63 into 100 and our answer is 1.586. And percentage of nitrogen, the mass of nitrogen in this compound, only 1 nitrogen, the mass is 14. So 14 divided by total mass of nitric acid 63 into 100. Then percentage of oxygen. Oxygen, 3 oxygen atoms are present. So 16 into 3, that is 48 divided by 63 into 100 equal to 76.19. So out of 100, if we take 100 percentage or 100 gram, 76.19 gram of what? Oxygen, or that percentage of oxygen is there, and 22.22 percentage nitrogen is there, and 1.586 percentage of hydrogen is there. This is about what? Mass percentage or percentage composition of that particular element.